Okay, in this problem, what they do is they give us a log function, it's y equals log 5 of x, and they ask us for a table and a graph. And in general, whenever we're doing things conceptually, so not with the magic properties of log, like the log of ab equals the log of a plus the log of b, we're going to have to remember that the logarithm function by definition is the inverse of an exponential function. Now, so every time we do this, I'm going to go over to the exponential function and do stuff there first. So how am I going to do that? Well, the first thing I'm going to do is remember that in algebra, they always made me rewrite y equals log of 5x in its exponential form by writing 5 to the y equals x. So this and this mean exactly the same thing. Now, remember to take inverses, you switch the x's and the y's. So if I switch the x and the y here, I get y equals 5 to the x over there. There's my original exponential function. Yay. Now, what do we know about that exponential function? The base is bigger than 1, so we know it goes up like that. We know it goes to the point 0, 1, and we know it has the negative x-axis as an asymptote. If I'm going to make a table of y values for the exponential function, I'm going to plug in 0 and get 1. And I'm going to remember that property of exponential functions where every time the x goes up by 1, you multiply by the base. So I'm not going to keep plugging in there. I'm just going to go from here to here, multiply by 5. From here to here, multiply by 5. From here to here, divide by 5. From here to here, divide by 5. And for the exponential function, I easily get my graph. I easily get my table. Now, what do I want? I don't want that one. I want the logarithm function. Now, what do I have to do? I have to switch the x's and the y's. Let's do the table first. I just take this table over here. I switch the x's and the y's, and I get my table of values for my log functions. You can see, by the way, that the worst thing I could have done at the very beginning was put my x values evenly spaced. Right? Now, how do I get my graph for my logarithm function? I just take my 3 properties over here and switch them. For example, this exponential function goes through 0, 1, so my logarithm function goes through 1, 0. My exponential function gets very close to the negative x-axis. So my logarithm function gets very close to the negative y-axis. And you can see way over here, my graph is getting more and more parallel to the positive y-axis. So my graph over here is getting more and more parallel to the positive x-axis. So that's how you actually easily write down a table of values for a logarithm function and easily get the graph.